So let's see how we find out expectation, variance, covariance of random variables. So by this time we understood what is a discrete random variable and a continuous random variable. Now for that case we will try to calculate the expectation or mean. Expected value is nothing but mean of that particular outcome. So when you do a random experiment you get lot of outcomes, and those outcomes are stored in a variable. I said random variable. It's called a random variable because all the outcomes are random for that experiment and which are represented using that variable x. Okay, so how do you find out the mean or expectation of a random variable? See an example of tossing a single unfair die. Okay, so you are trying to do die. Imagine a weighted die cheating. Imagine the following probabilities. So getting 1, the probability is 0.1. Getting 2 is this way. No, this is actually not true. To get 1, the probability is 1 by 6. But we are trying to change the values. This is just an example. Imagine the probability of getting 1 is 0.1, probability of getting 2 is 0.1, and so on. Probability of getting 6 is 0.5. Ultimately, what is our point here? Anyhow, when you make sum of these probabilities, it should be equal to 1. That is being satisfied. Now, how do you calculate the mean? Represented using mu or E of x. Okay, expectation. What is the expectation of random variable E of x? When you know the probability P of x of each value of x, for each value of x, we know the probability. Okay, we can calculate the expected value mean as summation of all those. Okay, point 1, how do you find out the expectation or mean? See, point 1, then point 1 plus point 2, then 1 2 3 summation point 3, then all these 4, that is point 4, then all these 5, that is point 5, then everything here. So we get it 3, right? So if you, it is 4.5. When you do summation of everything, if you do summation of all these things, you get 0.5, right? So the expected value is 0.5. See, you are multiplying x into its probability. Mu or expectation of x is nothing but the outcome of the event into its probability. X into p of x. So 1 into 1, then 1 into 2, then 1 into 3, 4, then 5, and this. And if you do summation of that, you get 4.5. Okay, whereas expectation of a continuous random variable with the probability density function is given as E of x is nothing but x into f of x dx. Okay, it is given as integration of x into f of dx. Next, variance of a random variable. How do you calculate variance of a random variable? A positive quantity. What is the variance here in terms of random variable? A positive quantity that measures the spread of the distribution. A positive quantity that measures the spread of the distribution of a random variable. So like this, no, I'll take an example. So if this is a probability distribution, so a quantity that measures the spread of distribution. So from where to where it is spread, this is your variance. Okay, so how do we calculate? Larger values of variance indicate that the distribution is more spread out. So this is the your example, a distribution. If this is small, this is no. If this is very large, means that variance is very big here. So how do you calculate it? The formula of calculating variance, that is nothing but E of x square minus E of x whole square. E of x square minus E of x whole square. What is E of x? We already seen the mean. E of x is mean. E of x is your mean or expectation, right? So using this formula, variance of x is nothing but E of x square minus E of x whole square. Okay. Variance, standard deviation is square. We remove the square symbol. Thus simply we write it as standard deviation. So the variance of a random variable, how to find out using these values? Okay, so it's nothing but summation. You can see this one. Then if I expand this definition, I get this. Then if you multiply this, what is x into e of x? E of x, I'm just trying to expand this. E of x square minus 2x into e of x, I'm writing it as e of x square minus 2e of x into e of x. Okay, so it's nothing but e of x square minus e of x whole square. Okay, e of x square, how to calculate? E of x whole square, you already know. E of x whole square means the mean square. But this one is reverse. E of x square. What is x? Your random variable. This example you see. Here, e of x means you got 4.5 because it's multiplication of both. This square I'm asking. This is okay. But what is e of x square? It means you have to find out squares of the values. You have to find out squares of the values into their probability. Summation of x square into their probability. This sum x square into their probability. Maybe in this case, in this example, it is 1 square into 1, 2 square into this, 3 square into this, 4 square into this, and so on. So that way you can calculate the variance of a random variable E, say summation of x square into p minus expectation square. Okay, so you see how we are trying to calculate variance of a random variable. Same example, let's take. See the same example, you have x equal 1 to 6 and probability of getting this one is 0.1 and so on. So x square p is this. How we got this? 1 square into 0.1, 2 square into 0.1, 3 square into 0.1, 4 square into 0.1 and so on. If you do summation, 23.5. And already we know its mean. Already we know its expectation, that is 4.5. So if you subtract that, it is 3.25. The variance of this probability distribution. Why it is called a probability distribution? Because it is nothing but the outcome along with its probabilities. So the variance of this probability distribution is 3.25 only. So it's a very small graph like this. 3.25 length. Okay. Similarly, standard deviation, nothing but square root of that, square root of this. So you get 1.803. Now, what is covariance? Okay, so we are talking about in distribution. This is a distribution. Why is this called distribution? We have already seen how we are trying to generate this. If you remember this example of this, no, identifying classification problem, how we have generated the distribution of the data. Okay, how we are trying to generate the data distribution and converting that into a probability distribution function like this, right? So we know we have a probability distribution. Okay, and we know this is the variance of it. Mean is the center point. This is the mean value. Mean value is the center point of that. Okay, now what is covariance? Covariance means what is the random variable. Covariance actually gives us the information about whether it is positive direction or is it negative direction. That probability distribution function, is it more on positive side or negative side? Okay, we'll see with an example, but the formula for that is this: e of xy minus e of x into e of y. E of xy minus e of x. E again, e represent expectation. So when you can find out covariance between two random variables. X and y are two random variables. How are those two related to each other? Okay. So take this example: air conditioner servicing company. Okay, air conditioners. Some just we are trying to find out its covariance. Given the expectation of x is 2.59, expectation of y is 1.79. How do you find out expectation of xy? You have to multiply all these things. 1 into 1 into 0.12, 1 into 2 into 0.08, 1 into 2, 3 into 0.07, and so on. Like this, you have to take plus 4, 3 into 4 into 0.07. You get this 4.86. This is the expectation EY. You have to multiply this value into the probability. Okay, both you have to multiply. You get this. So covariance is 0.224. What does this signifies to us? What is its meaning? Let's see. What does it means? Okay, so using covariance data, we try to find out correlation. This is what already we have seen. Positive correlation, negative correlation. How is that data distributed? Is it positively correlated or negative correlated? That we'll try to find out using correlation. To find out correlation, we need covariance. We have to find out covariance. So that is an application. When two sets of data are strongly linked to each other, we say they are highly correlated. Okay, when two sets of data are strongly linked together, we say highly correlated. So correlation is positive when the value increase together, correlation is negative when the value decrease together. Maybe you can take example of temperature and ice cream sales. Ice cream sales. When the temperature is increasing, it's obvious that ice cream sales will increase. So they are positively correlated because when the value is temperature increasing, ice cream sale is also increasing. Two different data sets, how they are linked to each other. That we are trying to tell using correlation. To find out correlation, we need covariance and variance also. So these are few examples. Positive correlation, highly positive, low positive, no correlation. Okay, we can find out the values. Yes, see, this is the example I was talking about, ice cream sales. So the temperature increases, ice cream sales are also increasing, right? So we can easily see that the warmer weather, the higher sales. The relationship is good but not perfect. Okay, the correlation is 0.9575. How to calculate this? How we get this? This is the formula of correlation. This is very, very widely used in data science. When you're doing data pre-processing, when you're trying to draw insights, we use this very important metric called correlation. Okay, so how to find out correlation of two data sets X and Y? I'm using the word two data sets now, whereas X and Y are the random variables which contain some outcomes. So somebody is doing experiment, generating some data, that data is represented as X, and somebody is doing another experiment, it is generating output, that output is your Y. So you're having data sets with you. So correlation between X and Y data sets is the covariance between X and Y by square root of variance of X into variance of Y. It can give any value between -1, 1. If it is 0, means there is no relation between those two different data sets. So how to calculate? See, temperature data is given, sales data is given. You try to calculate their mean. Mean is 18.7 and sale is 402. Now you try to find out mean from each of these parameters. Mean from this, mean from this, mean from this. You get these two parameters A, B. Multiply them, find out their squares. If you sum up, you get 0.9575. This is what how we calculate your variance and covariance. Okay, so once you calculate it, you get as 0.9575, right? So this is the procedure of calculating correlation. So we say they are positively correlated because 0.95 is closer to 1. It means when the temperature is increasing, 95% the sales are also increasing. So we have seen about how to calculate expectation, that is mean. We have seen about how to calculate the expectation, that is mean or expectation of random variable, how to calculate variance, and then how to calculate covariance, and also we have seen about correlation. So we are trying to calculate correlation using this formula. It gives the linking between two different data sets or the outcomes of two different random variables X and Y. So it is given using this formula. Correlation of X and Y is covariance of XY by square root of variance of X into variance of Y. This is an example which helps us to understand how we calculate the correlation. So we have positive correlation, negative correlation, and no correlation or zero correlation.